So I'd like to start by welcoming everyone to today's webinar, which will be talking about how to avoid costly errors on the shop floor using SOLIDWORKS MBD. So we're going to start with some quick introductions. I will introduce you to myself and to Javelin Technologies, for those of you who may not know who we are. And then we're going to move into what is model-based definition, SOLIDWORKS model-based definition, and how it can help us avoid costly errors. Then we're going to jump into a quick live demonstration of the product. And lastly, we're going to have a quick Q&A session together. So quick introduction on myself. My name is Vicky Guignard. I've been an application expert with Javelin for just over 3 years now. And I've actually been using the SOLIDWORKS solution platform for about 8 years now. My main experiences were doing structural steel and machine design. I am based in Edmonton, Alberta, and that's about it for me. So Javelin has offices all across Canada. We are a 100% Canadian owned and operated company. So we have offices from Dartmouth, Nova Scotia to Vancouver, BC. What that means for you is that we have support from 7 a.m. to 8:30 p.m. Eastern Time. So we have a lot. We have a lot of hours to help you if ever you have any technical questions. So we have over 100 employees, which are all certified in their own fields. So that makes sure that whenever you're talking with one of us, you know that you're talking with a professional. So Javelin is more than just an authorized SOLIDWORKS reseller. We like to introduce our products and services into 4 different stages of the product development lifecycle. So we have solutions to help you with your people, with your technology, all the way through your process, and lastly to your manufacturing. Manufacturing. So we know that manufacturing is really where you make all of your money, and we want to help you minimize the time and effort it requires to get your designs to your manufacturing, while always ensuring that your manufacturing has accurate information and that it always exceeds quality requirements. So I just wanted to show you this very quickly. This is the SOLIDWORKS Innovation Platform, just to show you how far SOLIDWORKS have gone in the last 20 years. So you know that SOLIDWORKS has been around since 1995, but officially 1997, and so has Javelin. We've partnered with them since they first started. So this is actually our 20th anniversary this year. And I just wanted to show you how far they have come. So when they first started, all they had was SOLIDWORKS mechanical design, right? Just the core SOLIDWORKS that you all know. But since then, they've developed products for every stage of your design process. So all the way from your concept to marketing, know that we have a solution to help you. So if ever you have any bottlenecks in your design process and you're wondering if there's a tool out there to help you, let us know, and I'm 100% sure we'll find something that will help you get to manufacturing faster. So finally, the product we all came here to see, MBD, which actually stands for model-based definition. So MBD is a set of tools that works with SOLIDWORKS. So yes, you do need to have SOLIDWORKS to work with MBD. It is an add-in to the SOLIDWORKS platform. So it's a set of tools that is used to present all of your product and manufacturing information in 3D formats, such as 3D PDFs, e-drawings, and Step 242 files. That's new as of last year. So PMI can include things like dimensions, tolerances, notes, or really any information that's required to communicate the necessary data about your model for it to be manufactured properly. So by using SOLIDWORKS MBD to define all that information directly in a 3D format, the need for a separate 2D drawing is completely eliminated. So you no longer need to spend all that time on your 2D drawings. So since it guides manufacturing directly into 3D, it drastically streamlines production. It will cut cycle time It will reduce errors, and overall it's going to improve the quality on the shop floor. So I'd like for us to take a quick second to see how things are being done today. So you can see this 2D drawing, right? 2D drawings have been around since the beginning of time, really, from hand sketches to 2D solutions and now to SOLIDWORks. Now, 2D drawings can really quickly get cumbersome and hard to understand. For example, a part like this that has so many details, so many section views, it's really easy to misinterpret information on a drawing like this. And from data that we've gathered from previous polls, a third of engineering dollars are spent in 2D drawings. That's a lot of money. Yet up to 60% of them don't even match the 3D models on the shop floor. So all of this money is involved in creating those 2D drawings, yet you're still losing money with those drawings on the shop floor. So we need a solution for that. Now, who's MBD for? Who's SOLIDWORks MBD for? It's really for any manufacturer who wants to avoid misreading or discrepancies of 2D drawings from their 3D designs, which will usually result in scrap, rework, or even quality issues on the shop floor. So anyone who wants to avoid all this, that's who MBD is for. So my guess would be really for anybody who's doing 2D drawings. So I'm not going to spend too much time on this. I just wanted to quickly show you this quick study that NIST did. NIST stands for National Institute of Standard and Technology in the USA. So SOLIDWORks wasn't directly involved with this study, but really what they did is, well, the gist is for those three parts that you see here on my slide. They tested these models through semantic PMI definition, CAM, and CMM. So they tested both model-based approaches and drawing-based approaches. And overall, they saved over 70% of their cycle time using the model-based approach. So I got this study in a little bit more details here. So you can see the number of hours spent on each part and for each process. So from annotation, so that's creating all those 2D drawings, to the machining and the inspection. So you can see that the drawing process, you're not saving that much time, right? In what they mean by that is by including all of the PMI data and information and all that. So that's not really where you're saving your time. Where you're really saving your time is communicating with the machinist on the shop floor, right? So for example, for this part, they went from 73 hours to 3.7 hours. That's huge. Now, at the end of this webcast, I'm going to put the link of that study in the chat box. So if you're interested, you can go read about it and see in more details what the study was all about. So that's another study that NIST did with this part. So we have the model-based part on the left side and the drawing-based part on the right side. And you can see that the drawing-based part, one of the errors was that they drilled it through hole in the part, this through-all hole, which is not what the part was meant to have. It was supposed to have a hole that was to a certain depth. So what happens there is they need to scrap those parts. They need to pay a guy to redo all those parts. And if you're maybe tight in time for project, maybe you have to pay that guy during a weekend, so paying overtime. It's just a lot of money for just a dumb hole, right? So you want to make sure that the information is well understood on your shop floor. So let's jump into the live demonstration and see what MBD is. So just before I get started, I just want to walk you through what it is we'll be seeing during that demonstration. So I will be showing you how easy it is to incorporate all of that PMI data inside the 3D models. We'll see which tools are being used. And once that process is done, we're then going to capture those into 3D views. Once those 3D views are all created, we're then ready to move, output this into industry standard formats like 3D PDFs or e-drawings. And lastly, we're going to talk about the 3D PMI Compare Wizard, which is actually a new tool as of 2017 that I love, and I'm really excited to show you guys today. Okay, so we'll start with creating that PMI data. So I just jumped to SOLIDWORKS. This is the SOLIDWORKS interface that you all know of. So what we have here is the part that's actually already completed. So I've got several 3D views here accompanied by all the PMI data that is required to manufacture those parts. So you can see up here that the SOLIDWORKS MBD add-in is just another addition to your toolbars up here, and that all the tools you need to create those views will reside right here in that toolbar. So this is actually a gear plate part. I'm going to close this off and show you where that gear plate belongs. So I'll just open another part for you guys. Give me a second. Actually in assembly. So for example, there we go. In an assembly like this, which is actually an underwater camera housing, we really have precise fits through all of these parts. We need really tight tolerances, for example, where all of these gears mesh together. Right? It's really critical that we have accurate dimensions for this assembly to function as intended. So obviously this can mean really high cost, but if we carefully consider geometric dimensioning and tolerancing, we can actually lower costs in some cases if it's done properly. I'm just going to show you those 3D views here. And let's see how this part is assembled. So the process of setting up a fully detailed 3D model like this one is pretty straightforward. The first thing you need to do is consider how the parts are going to be assembled to one another. So for example, we've got our gear plate here, which is mounted on our base plate here using these two bolts. Pretty straightforward. So with that in mind, we know that the gear plate needs to be dimensioned in such a way that's going to ensure that all of these gears mesh together correctly. So let's work on that gear plate. Perfect. I'm just going to open up that tab here. So you notice here at the bottom, I've got my 3D views tab. This is where I will store all of my 3D views. So we already have a couple of 3D views that have been created for us. We've got an ISO view, which is where we're going to have all of our dimensions. And then I've got an overview view, which is where maybe I would like to add maybe a set of notes, which is something that we would typically show in a title block of a 2D drawing. So I can show that in a 3D view like this one. So I'm just going to go to my design library and bring in a set of notes. So by the way, guys, this is something you can do. If you have standard notes, you can just save them to your design library and then drag and drop them into your views like that. Just going to bring it back a little closer, right here. Now, instead of having just done text like this, maybe I want to tie it to custom properties. So for example, my material, I don't want to type it in because that's prone to errors, right? Whenever you type something in, that's prone to errors because if something changes and you forget to change that field, then your note is no longer good. So I'm going to link it to a property, to my parts property right here, and now it's populated with the accurate material. So I know that this note is always going to be accurate and up to date, again, reducing the chances for errors. So I'm going to go back to my other view now. So the first step in detailing this part is going to be to determine where I want to position my manufacturing datums. Where are those manufacturing datums going to be? So as we know that the part is going to be bolted in place on that base plate, this space is going to be my datum A. Now, to add datums, super simple with MBD. I'm just going to go to my auto dimension scheme. And in here is where I'm going to set all of my datums. So I need to first tell it if my part is going to be a turn part or prismatic, the tolerance type that I want, plus or minus or geometric. I'm going to say geometric for this one. And then the pattern dimensioning, if I want it linear or polar. In this case, I'll say linear. So my primary datum will be this bottom face. My secondary datum will be the inside bore here. And then for my tertiary datum, I'm going to select the gear shaft right here. Now, if we take a closer look at this gear shaft, we know that it's a continuous hole right between these two plates. So what I can do is create what we call a compound hole by selecting those two holes to specify that this would be drilled into one step. Now I'm good. And now I've got the option to either dimension all the features or just selected features. Now I'm going to specify selected features and choose these two holes here, and then the rear bearing hole that I've got there. And then I'm simply going to accept that. And SOLIDWORKS just does all the work for me, right? It's automatically added all the datums, the dimensions, and geometric tolerances for the selected features that we just selected. Also, the great thing that it does is it's going to show me which faces or which features are fully defined by color coding the faces green. So this is the DIM Expert tool. That's one thing I should have mentioned. The DIM Expert, SOLIDWORKS MBD uses the DIM Expert tool, which is already there. It's already a tool that's inside SOLIDWORKS to dimension the parts. So in the DIM Expert Manager, this is where everything will be stored. Now I may prefer to see these annotations as a list. So what I can do is just go to my tree display and say show annotation base tree. Now if I hover or click over any of these items, they will actually highlight on my screen. That's actually a big advantage over interpreting a 2D drawing, right? You don't have that function inside of a 2D drawing. So we're already seeing how creating PMI is super easy with the DIM Expert tools. It almost does everything for us. Now we're going to move into creating more 3D views and adding more PMI information in there. Oop, I want to go back here. Perfect. All right, so now we're going to flip to a top view. So in my annotation folder here, I've got all of my views. So I'm simply going to go to my top view. And right away we can see that it's automatically recognized those two mounting holes and added that dimension to my top view. Now the location of these two holes still needs to be added. We don't have that information yet. So what I can do is simply recreate the basic dimensions here of location of those holes, and it will be added to my top view. Now I'm still missing some information here. So if I rotate, I'll see more dimensions that were added previously. So what I can do is simply select the dimensions that I want to include in my top view and bring them to my top view. So if I go back to my top view like this, I'll actually go to my normal 2, my dimensions are in the proper view. Once I'm happy with that, again, it's as easy as taking a snapshot of this. I'm going to say capture my 3D view. Sorry. I'm going to leave it called top. Now, optionally, I could include the annotations from other views, but really what I want to have clean views that I don't want too many information on all of my views. So I'm only going to keep the annotations from my top view and accept that. Our next step is going to be to create the front view. So I'm going to go to my front view right here. Now the front view is already quite completed. Maybe I want to add the vertical dimension that locates that hole. So I'll do just that, actually this one, to add that dimension, maybe relocate a couple dimensions and accept that. So once I'm happy with my view again, I simply capture that 3D view. I just want the information from my front and accept that one more time. And it's really great that we have those thumbnails at the bottom. It really helps you keep track of the information you already have. So while we're still in this orientation, maybe I wanted to mention that pattern of holes that we have here. So again, I'm going to use that auto dimension scheme to do that. My part is still a prismatic part, but this time I want a plus and minus tolerance type. For my pattern dimensioning, I'm going to say polar and then specify my datum, which will be this one. And again, select the features that I do want a pattern. So I'll select one of those holes and then simply accept that. So so right away, I've got all the information for drilling those holes. So SOLIDWORKS has actually recognized and highlighted all 6 holes in one quick click. So all the information that we need for the bearing bore, the rear bearing, and actually the hole pattern is available in this view. Now I may want to create a view that's specified only for those holes and no other information. So what I can do is create my own view instead of using a standard one. So the way we do that is here. I'm going to say, sorry, where is it? Oh, right here. I want to create my own view. Insert annotation view. Sorry, I had a blank for a second. Now the orientation for that view is front. I go next. And in here is where I'll specify the annotations that I want to move to that view. So the only annotations that I do want for those will be the annotations that are for that that bold circle. So I'll choose these ones. Actually, it's not that one. This one, that one. Oh, and this one. Perfect. And then when I'll click OK, I'm now ready to capture this into a view. So I'll say capture 3D view. I'm actually going to call this one flange holes so that the machinist can quickly find the information for the flange holes. And I just want the information that we moved on to that newly created view. So only these 3 dimensions. Okay, now let's go to my right view. Very quickly, I'm going to activate and reorient my right view. Straight away, I can capture this view and add my dimensions manually. So I only want the information for my right view, accept that. So in our sets of our SOLIDWORKS MBD sets of tools, we have a lot of additional tools. We can use the auto dimensioning scheme, but maybe we'll want to approach it with a more manual process. We have the option to do that. So for example, I could choose my location dimension. And then maybe I want to dimension from this face to the other side. Now you'll notice when I click on this face, it only selects these faces here. That's because the surface is broken. So what I can do is, again, do another compound plane by selecting those faces and then dimensioning to the other side, like this. And then I'm simply going to go ahead and dimension more faces like this. I'll add a couple dimensions just to make this look right. Now for time purposes, I'm not going to add all the dimensions that I would typically insert. I just want to show you how quick and easy the DIM Expert works with SOLIDWORKS MBD. So this is for my location dimension. I can also add size dimension, right? For things like maybe for this fillet, it will automatically capture the fillet. Same thing for the chamfer. If I only select the chamfer face, SOLIDWORKS recognizes the feature and applies the chamfer dimensions for it. Same thing for these holes. Automatically recognizes that there are 2 identical holes right here. So let's say that I'm happy with this. Again, I'm going to capture that view, and that will be my left view, I think. No, that's actually my right view. There, I'll have 2 right views. So let's say we're happy with all of these views. We could do even more things. If I wanted to add a section view, I could always do that and then capture it. Adding section views is really as easy as it is with SOLIDWORKS alone. There's really nothing new to it, except that you capture it into a 3D view. So once this is done and we're happy with all of our views, It's now time to export those into industry standard formats. So we saw how easy it is to create all of that PMI information, capture that into 3D views super clearly. Now we're going to talk, like I said, about the outputs. What kind of outputs can we create with MBD? So if you look at my toolbar up here, I've got many things I can do. I can export it to a 3D PDF, publish it as an e-drawings file. I can publish a Step 242 file. Those are the options that we have here. So if I wanted to publish this to a 3D PDF, I'll just show you how that works. So, SOLIDWORKS MBD does provide you with a complete library of templates to work with. You can always create your own. You can always modify those library templates if you want to add your own logos, your own text, and so on. So let me just open a part file. Then we choose the views that we want to incorporate in that 3D PDF, the accuracy level that we want, maximal, high, or low. If we want to attach any file, so if we want to attach maybe a Word file, a vendor approval form, we could do that. And then lastly, if we want to create and attach a Step 242 file to that 3D PDF. If I move on here, I'll just show you this very quickly. This is all the custom property information or metadata that we can tie into that 3D PDF. So things like dates, materials, part numbers, revision numbers, and so on. That is all driven from your custom properties here. So once I'm happy with that, I'm simply going to click OK. Save that. It's going to take a few seconds because it is generating all of those 3D views and that text inside my 3D PDF, and then it's automatically going to open 3D PDF, which I'll show you in just a second. So this is what the 3D PDFs look like. Super, super slick. You can have your standard notes in there. If we toggle between our views here, you'll see the text and all the dimensions that are there. It's a full 3D environment. You can zoom in, zoom out. If you want to take dimensions, you can always do that. And like I told you earlier, these fields are all customizable, right? This is the standard template that MBD provides, but if you want other fields in there, you can always edit those through the template editor, which is this little tool here, this little guy. If ever you want to add comments, maybe I want to add something to my supplier, like how large is the order? I can always write that and then send that to whoever needs that 3D PDF. So super quick and easy to generate those views and to create those 3D PDFs and those e-drawings file. I'm already 4 minutes over my time here, so I'm going to try to go a little quicker for the last step. It's the 3D PMI Compare tool. It's a super awesome tool, which I'll show you here in a second, which lets you open an old and a new version of files, and it will literally compare the two and show you any modified data. So the way it works, I'll just show you that very quickly. I'm just going to close this file here. Oh, by the way, I just showed you for a part, but you can do the exact same thing for an assembly. Just give me a second. Okay, so the 3D PMI Compare tool. Here's where you'll choose your reference documents, so the old and the new version. So I'll choose, let's say, version 1 of a part. And then I'll choose my version 2 of another part. Well, of the same part, I should say. And then I'm simply going to hit Run Comparison. So what the 3D PMI Compare tool will do is that it's going to run through the entire model, find any unique data and any modified data and color code it for you. So you can see that bluish gray color. This is the information or the data that hasn't changed since the last version. The green one is the modified data, so you can see that these values have slightly changed. And then the purple data is any new data that's in there. So really, really helps you if you're doing any type of revisions on your files and you're trying to find information. So with all of these tools, it's really going to streamline your process. If you're doing any types of 2D drawings and you are having issues on the shop floor communicating all of that information, I'm 100% confident that SOLIDWORKS MBD will help you just solve all of those issues. When you have a very complex part, it's really hard to detail it enough so that the person on the shop floor truly understands the design intent and all of the important information on that part. It's really easy to get carried away in creating a 100-page drawing package for a part, just trying to detail it. With MBD, there's no way you can go wrong, right? You're in the 3D model. You see the part. You can question the part. You can take measurements wherever you want to. So those 3D PDFs, people can open it on the shop floor on a computer, or they can have a tablet. So not only are you saving the planet, but you're making your whole design process much, much easier and faster. So just to wrap things up, SOLIDWORKS MBD, exactly what it does. It will create the PMI information directly in your 3D model. It will organize all the data into 3D views to effectively convey manufacturing information. You will be able to publish and share all of that manufacturing data in industry standard formats, e-drawings, 3D PDFs, Step 242 files. And all of this will result in a much better understanding of the PMI on the shop floor and lead to reduced errors, which in the end will save you a ton of money.